Hi all, I'm Dr. Sujya, Assistant Professor in the Department of Computer Application at Dr. SNS Rajalakshmi College of Arts and Science. And today's series of topics I'm going to discuss is about minimization of Boolean functions and why minimization of Boolean function is important in Boolean algebra. So minimization of Boolean function, which is represented as logic expressions in terms of a sum of minterm and a product of maxterms. And these are literally increases the complexities of the digital circuit. And this can lead to large and insufficient circuits. So to overcome this, minimization of Boolean expression has been introduced. And this is the main focus on this is to reduce the number of logic gates by simplifying the circuit design and by improving the performance in terms of speed, cost, and power consumption. So this is the main motto of minimizing the Boolean functions in Boolean algebra. And so there are various methods and techniques for minimizing the Boolean functions are the Karnaugh maps, Quincy method, and the use of Boolean algebra is also used to achieve simplifications of the algebraic form. And when talking about the Boolean algebra, we have certain rules and laws that has to be followed, like the distributed law, associative law, and complement law. And these are used for simplifying the Boolean expressions in order to reduce the complexities of the expressions by eliminating the redundant terms. So what are the rules and what are the laws that has been there in the Boolean algebra and how it is expressed in terms of parameters? So first law is the identity law, and the next law is a null law, and next is the idempotent law, next is the complement law, next the domination law and double negation law. Then we have the distributive law and we have the De Morgan's law and observations law. So these are the laws that has been used to reduce the Boolean expressions in form of simplification format. So this is focused on eliminating the redundant terms, and these are the expressions how it has been followed by the rules and laws of the Boolean algebra. The most popular simplification problem here we are going to see is about the Karnaugh map. It is also known as K map, which is used to minimize the Boolean expressions and in terms of equation manipulation. And this K-map comes in special versions by representing it in a truth table format. The expressions are SOP form and POS form. SOP is sum of product form, which works on 3 variable K-map and 4 variable K-map. In case of product of sum, it works on 3 variable K-maps and 4 variable K-maps. So these are the popular two forms that has been used in and Karnaugh map. So when talking about Karnaugh map, it is a numerous digital circuit and it is used to minimize the variable, which is prerequisite, and it works for minimizing the Boolean expressions that have 3 or 4 variables of simplifications. So this will be discussed further with an examples. And so how a Karnaugh map is used. Solving an expression using Karnaugh map are first a K-map is selected according to the total number of variables, and then we have to identify the max terms or min term as given in the problem, and then we have to put 1 in the block of K-map with respect to min terms, else it can also be replaced with 0. And for POS, putting zeros in the blocks of K-map with respect to max terms and making rectangular groups that contains the total terms in power of 2 such as 2, 4, 8 and trying to cover all many numbers of elements as it can be a single group. From the group that can be created in step 5, we have to follow each steps to simplify the map finally. And the sum of product form of 3 variable K-map here, z is equals to summation. Here the SOP form is mentioned with a symbol of summation sigma. So P, Q, R, which has 3 variables, which is mentioned as P, Q, R. which is given a value of 1367. So this 1367 has to be represented in the truth table, where we have taken ABC as 3 variables with 0, 0, 0, 1, 1, 0, 1, 1. So here we have to follow a term is, we have to replace 3 and 2, and the downwards we have to replace 1 and 0. So finally 1367 places has to be filled with ones, and this is how a grouping has been done. So this is SOP for the 3 variable K-map. And that is 4 variable K-map is where PQRS, the 4 variables I have taken literally, which are PQ and RS, which is mentioned, and this has been designated with a value where all the values which is being given in the set braces has to be mentioned in the form of 1. So, in what is the speciality of K-map is the maximum grouping we have to perform. First, we have to look for 8, and we have to look for 6, and finally we have to look for 4, and finally we have to look for 2. So this is how it is being grouped in a K-map for simplifying the process. So in this blue color, it is highlighted that K-map is assumed to be connected, so we can make it in group in this way. And also in case of max term, we have to try to focus on 4 connected groups. This is of 4 variable K-maps. Thank you.